can say it on. Let's start off. So last thing we did was this grid. Let's see a variations of this maximum minima, which you'll actually encounter. Hope everyone went through the notes and started solving those sheets which I sent. So later on, we'll study this in electrostatics. Let's say if you have a charge Q and a charge Q, and if you have a minus Q charge, right? And this distance is X, and this distance is D, and this distance is D. The force on this charge Q, because these two will be attracting, no? This charge will attract this way, this charge will attract this way, so the resultant will be downward. So this force F is given by C into X by X square plus D square whole power 3/2. Now don't worry how we got this. That is not important. We know the function somehow. So Cx by X square plus D square whole power 3/2. C and D are constants. So basically this is the force on the minus Q charge due to the 2 plus Q charges on either side. On perpendicular bisector of the plus Q charges. That is given. So the question is, find X if the force is maximum. Get it? This is simple differentiation. There is nothing big there. Like I said last time also, right? Getting the equation is a headache. If you got the equation, then it's just a matter of differentiation. Try. I'll give 2 minutes. I hope the question was clear. So there is a minus Q charge and there are 2 plus Q charges. The particle is at a distance of X from the perpendicular bisector, along the bisector. The force is given by C into X by denominator X square plus D square whole power 3/2. C and D are constants. Find the value of X so that for maximum force. Any answers? Find X for the maximum value of F. What is step 1? Differentiate and equate to 0. Step 2, you have to do a second differential, but not required. Because if I ask you for maximum force, generally it is understood you'll get that same thing. One by root 3. नहीं रे, answer D में आएगा Dhrit. Answer should come in terms of D. Check. Others, anyone else answers? Venkatesh, I can't see you clearly. Anonymous Jackal. To change your name.
So sorry, sir.
That's an interesting name, but change your name. Malika, adjust your camera a bit. Yep. Palaksh, same thing, still foggy, but still adjust your camera a bit down. Make sure I can see your full face, everyone. Seriously, no one got the answer. Just differentiate, no? F is cx by d square plus x square whole power 3 by 2. You just need to differentiate df by dx. How much is this? C is anyway constant. So this is d by dx of x into, I'll write this thing as x square plus d square whole power minus 3 by 2. Like I said, I don't like division rule actually. I like to write everything in terms of product rule. So this is your f of x and this is your g of x. You can do division rule, nothing wrong. For some reason, I don't like it. So this when you differentiate it, this will be x square plus d square whole power minus 3 by 2 and dx by dx plus x comes out and then differential of x square plus d square whole power minus 3 by 2. Remember, you have to use chain rule for this guy. So this will be x square plus d square whole power minus 3 by 2 plus x into, this will be minus 3 by 2. That looks like x power n. This thing looks like a function to the power of n. So n into x square plus d square whole by 3 by 2 minus 1 and then differentiate whatever is inside. I hope you remember the chain rule there. Simplify further. This is a question actually from electrostatics or gravitation, 2 chapters. This will be minus 3x by 2. This will be x square plus d square whole power minus 5 by 2 and this will be 2x. This you're saying equal to 0. So then you just end up with x square plus d square whole power minus 3 by 2 is equal to 3x square plus d square whole power minus 5 by 2. Send it that side. This will become x square plus d square is equal to 3x square. We get x is equal to d by root 2 plus or minus. One is a negative value, one is a positive value. That is happening because there are actually two possibilities. You can be on this side or you can be on the either side. So this is positive x, this is negative x. Because see, Max doesn't understand the meaning between plus f and minus f. Max will think minus f is smaller, but in physics, minus f means what? Direction is reverse, right? In physics, when you say plus 5 and minus 5, what is the difference? Plus 5 means you're going forward by 5, minus 5 means you're going backward by 5. So negative actually kind of indicates direction. Max doesn't care about that. Max will simply think plus f is greater than minus f. So in this case, actually, there are two positions of maxima. And if you ask me, sir, what about minima? Minima will be 0 at the center exactly. Both the charges will push with same force. But anyway, don't worry about that. But this is a standard result also. We will see when we do it in electrostatics. Do have a look at this. Ronak, you got it right. Please check. There's nothing there other than just brute force differentiation. There's nothing logic, nothing to think. Got the equation, differentiate and equate to 0. This level of differentiation you should be quite comfortable with. Any doubts? Any step you're not clear, not convinced, please ask. Clear? Next thing. Can I turn the page? Next, rate of change. So whenever you hear the word rate of change, it can be anything: rate of change of position, rate of change of velocity, rate of change of temperature. So it is nothing but any quantity. If you differentiate with time, it is called rate of change. Any quantity that is differentiated with respect to time, we call it rate of change. Pretty simple, basic there. It is just a differentiation. But if you differentiate the time, it is called rate of change. Example, how will they frame questions on this? Let's say a radius of a circle is increasing at a rate of 2 centimeter per second. Meaning he's simply saying rate of change of radius dr by dt is equal to 2 centimeter per second. So every second the radius will increase by 2 centimeters. Find the rate of change of area. Meaning then how fast is the area changing? I'll show you one example, then we'll do more on this. Rate of change of area at t is equal to rate of change of area when r is equal to 10 centimeters. This is a question. Okay. So what is area? Area A is given by pi r square. So you're asking me to find rate of change of area. So this is dA by dt. Now listen carefully here. There are two ways to do this. I'll show you both. You see which is convenient for you. Now, first thing, you're differentiating with respect to what? Time. But what do you have here? R. So it is not the same variable. So dA by dt is pi d by dt into r square. So this is like a chain rule. You're differentiating something to the power of 2. This is not t inside. So this will be pi into 2 into r dr by dt. Since you're differentiating a function which is not time, suppose if it had been t square now, t square ka differential will be 2t dt by dt, that used to become 1. So we always used to write 2t. But here you're differentiating, look at what is happening. A is depending on r, but you're differentiating with time. This is one way to write it. Now, if you're not okay with this, you didn't like this, another way to do this thing is a is equal to pi r square. Since a is depending on r, differentiate with dr. This will be pi into 2r. Send dr that side. Divide by dt on both sides. That will be dA by dt is equal to pi into 2r dr by dt. I hope you're getting the difference. Since a is depending on r and you're differentiating the time, so you're bringing a new variable. So it is like a chain rule. R square ka differential will be 2 into r and then differentiate r, whichever is inside. There are two ways to do this. This is the actual thing. But if by chance you're getting confused, this is how the logic. Please have a look at this logic here. It is little different because till now what we used to do now, let's say y is depending on x, you always differentiated y with x. If y was depending on time, you differentiated y with time. So there was no problem till now. But abhi for the first time you're doing y is depending on x and you're differentiating with time. This will be dy by dt will be dx by dt. So yeah, it is little that way. So please do have a look at this. How did I get from here to here? Once you got this, question is over. Pi to r is how much? 10 centimeter given. Dr by dt is how much? 2 centimeter given. Substitute here. So that will be 2 to 4, 40 pi centimeter square per second. So every second the area is changing by 40 pi centimeter square when r is 10. Please look at this example. We will do a few problems like on this based. So this is called rate of change. So we have done maximum minima. That's a different category. This is a different category. Anyone not convinced with this, not clear, confused, please ask. 80-90% you're clear, then it is fine. When we do problems, you'll get the better hang of it. Venkatesh, I think your cam is going crazy. You can switch it off and switch it on after some time. Any doubts on this? All clear with this? Malika, Abhinav? Clear? Swastika? Rehan? Great. Adrit, Arjun, Vidyut? Clear? Ritu? Sure, no? Mayuka, Ronak? Palaksh? Aryan? Great. Let's see a
Yes,
question.
sir.
So let's do a simple one, then we will take it more. Like we got a cube. A cube of side A right is changing at a rate of 2 centimeter per second. Find the rate of change of surface area and rate of change of volume. When A is equal to 3 centimeters. Get this easy one.
The surface area here is the total surface area, right?
Total surface of a cube. 6 faces, no? $72 and $54. Okay, we have two answers. $54, okay. Let's see. So the surface area will be 6A square. There are 6 faces. So dA by dt will be 6 into A square ka differential is 2A square into dA by dt. So this will be 12. A is 3 and dA by dt is 2. This is 72 centimeters square per second. Volume V will be a cube. So dV by dt is equal to 3A square dA by dt. So 3A square will be 9, dA by dt is 2. 54 centimeter cube per second. Easy? Check out the steps. Next one. The rate of change of volume of sphere is 10 centimeter cube per second, when r is 1 centimeter. Find rate of change of surface area. This time reverse. I gave you volume and asking for surface area. Till now I was giving you the radius and asking you volume and surface area. Same thing, we just twisted a bit. Get it? We'll finish our differentiation today. We'll be starting off with integration. Integration is small. Compared to differentiation, mathematically it is small, but applications are pretty huge. Mostly we should wrap up integration also in the next week. We'll start with kinematics after that. Try. Everyone should give it a try. Five by 2 pi. Okay. Others? T pi. Okay. See. First volume is 4 by 3 pi r cube. So dV by dt will be 4 pi 3 pi. This will be 3 r square dr by dt. R cube ka differential. And you're saying this is 10. 3 goes off. 4 pi and r is 1. So dr by dt is 5 by 2 pi. This is dr by dt. I didn't ask you this. I asked you for surface area. So surface area of a sphere is 4 pi r square. Hope you know these things. You should don't know, you need to remember that. Volume is 4 by 3 pi r cube, surface is 4 pi r square. So ds by dt will be 4 pi r square ka differential is 2r dr by dt. So basically you calculated dr by dt from here. So this will be 8 pi, r is 1 and dr by dt is 5 by 2 pi. 5 pi goes off, that will be 4 and that will be 20 centimeters square per second. Check. Pi won't come, right, Ronak? Check where you messed up. Adrit, you got it right. Aditya, check your answer. Clear? Any doubts on this?
Over here, what is dr by dt like in the first
dr by
case?
dt is what? Rate of change of radius now.
Yeah, okay.
dr by dt is rate of change of radius. That is not given. That is what we are trying to find actually. Easy? All got this? Next thing. Let's say we have a cone completely filled with water. So there's a small hole at the bottom and the water leaks. So for some reason, water leaks at a constant rate. In reality, which is not true. V centimeter cube per second. This is radius r and this is the height h. So as the water starts leaking out, right? Water keeps coming down, down, down. The height is decreasing. So h is the height of the liquid at any instant. Height of the liquid at time t. So question is find dh by dt. Find dh by dt when the height is small h. Basically, what I'm asking, with what speed is the water level coming down? dh by dt is nothing but rate of change of position. So at what speed is the water level coming down? So that means if we keep a piece of paper here, the paper is actually going down continuously. So the actual question would be something like find the speed at which the particle is moving down. Right. So if you see, we are still, I'm asking a rate of change of height. But I gave you a physical system now. I didn't give you an equation. Try. Finish off. This is the last one for differentiation. We'll start off with integration after this. Any doubt so far? Anything you're not clear, please ask. So this is a cone. Radius r and height h. Do you guys remember the volume of a cone? If someone doesn't know, volume of a cone is 1 by 3 pi r square h. You should know all these values, right? Formulas 1 by 3 pi r square h. That is the volume of a cone if someone doesn't know.
Sir,
Every second volume.
R is constant.
R कैसा constant होगा Adrit?
The cone is the same, no?
Okay. R of what you're asking? R of the
Cone.
water or R of the cone?
R of the cone.
Cone will remain same. But will the water remain same? What is the water now? ये है ना water god. You mean to say this R will remain same? Na? You're asking that R, na? You're not asking this R. This R will remain same. This won't be R. This will be something else. As the height is changing, the radius of that the water cone is also changing. Try. Are you 2 minutes? Think about it. Next class will be very important. Integration, don't miss. 0. 0 to chance. Let's see how to do. So let's say after time t, the water level is still here. Let this be small h, let this be small r. Okay. And if you look at this thing here, angle, if you take this angle is theta, this was capital H and this was capital R. So there's actually a relation between them. Tan theta is capital R by capital H. Tan theta is also equal to small r by small h. So this is the relation between small r and this thing, r small h by capital H. Got it? So the ratio will remain same. So now after time t, what is the volume of that water? Volume of water, V will be 1 by 3 pi small r square h. And this thing 1 by 3. Now there are two variables, right? I don't want two variables. So r ko replace kar lete. R h by h. How do you know which one to replace? The question is find dh by dt. Means you don't want small r, you want h. So pi by 3 capital H square r square h cube. This is V. Differentiate with time. This is rate of change of volume dV by dt. This is pi r square by 3h square into h cube ka differential is 3h square dh by dt. What is this? This is the rate of change of volume, right? That means how fast is the liquid flowing out. That is nothing but rate of change of volume. I'll just write this as VW. Okay. This is nothing but V only. Given rate of change of volume is V centimeter cube per second. Every second volume is leaking out at a rate of V centimeter cube per second. So that is given as V. 3 gets cancelled. Pi r square h square by 3h square dh by dt. You're done. Just send everything. That's how you get the answer. 3v h square by pi r square small h square. That's your answer. And did you observe one thing here? The rate of change of height is inversely proportional to h square. Meaning the smaller the height, the faster the height will change.
Sir,
As the height is decreasing.
These 3 should cancel above and
3 cancel हो जाएगा. Yeah, right. 3 नहीं होगा. Check. I hope this was clear. Not tough, but main thing is what you should know that small h and small r are related. So you have to bring the entire volume of that liquid at time t in the times of in terms of small h, and then just differentiate. Clear? Any doubt? So this is another model in differentiation, rate of change. So these are all the applications. Maximum minima is 1, rate of change is 1. As we proceed, we will encounter more and more. All this calculus stuff will again you'll encounter in kinematics. Like I said, physics, every chapter just keeps piling up. We did vectors, we use vectors in differentiation also. Then calculus and vectors we'll use in kinematics, and so on. Clear? Turn the page. Rehan, clear? Ritu, got this? Next thing, integration. Like I said, the entire calculus, right? Max people will teach you almost for 3 months. We are not interested in that. We are only interested for the applications part. So let's see what is this integration about. So integration, if you see, it is especially useful when quantities change. I'll tell you what it means. Let's say we have a simple rectangle y, x1, x2. So the area of a rectangle is given by the breadth into height, that is y into x2 minus x1. We can simply call this y into delta x. Delta x is nothing but the change in the x coordinate. This is simple. We learned this thing in the basic stuff. This is rectangle, area of rectangle. The problem is, what happens if you take a curve? So basically, calculus is especially important when you're dealing with variables. What if you have a random curve like this, and if you try to apply the same logic here, let's say this is x1, this is x2, great, and you're trying to find this area here. So area under the curve, we face a problem. If you try to use a rectangular curve formula, which is length into breadth, that is y into delta x. Problem is, what is y? This y changes at every point. We don't know y ka value. This actually creates a problem for us. You're getting it? So we can't use the rectangular formula directly to find area under the curve because the height will keep changing. Suppose if you take this point ka height, then you're actually measuring this area. If you take this point ka height, you're actually measuring a bigger area. So if you take this height, you're measuring this area. So you get a lot of errors. So what is the technique for this? So what we do, we divide, we choose a small part, and so what to do for this? We need to choose such a small part. We need to choose small dx or small delta x, where we can assume the y is almost constant. I'll tell you what it means. Now see, this is just for you to understand what is integration. In terms of solving, it really doesn't matter. We really don't care much, right? So we can assume y is constant for that small part. So what is the idea there? This is what you're planning to do. So this curve which you have, we will take such a small piece, small slice actually. So like the small slices we will take. Now, when you look at this slice, it is actually kind of like this. It is not proper. So this is very small dx. So what we are saying is, I will just assume this as y. And this small part is there, this is the error actually. So area of this thin strip. You can say y into delta x, where y is the height of the strip. So basically at different points, you have different coordinates now. Let's say this is y1, this is y2, something y3, right? So you can say this is the height of the yn. So yn is the y coordinate of the nth strip. But the thing is, this thing, right? So there's an error. There is an error in this. You won't get exact answer here. There is an error. Because when you take it very small, there is an error there. You won't get a proper area there. And what's the best part about this? You actually use this in everyday life. You just don't realize it. Did you ever think about it? Right now when I'm speaking to you, what you're hearing? And how does a recorder record your voice? Do you ever see this thing in a audio ka file? 128 kbps, 320 kbps. Did you ever see that end of the file ka name? If you ever download a music file, you'll see this term there: 128 kbps and 320 kbps. Seen that? The meaning of it is, see, this is what happens in a digital recording. Let's say when I'm speaking or you're speaking into a mic, your voice is actually kind of like a curve. This is called an analog signal. Literally, the signal is there is a continuous signal. This is a signal ka whatever is amplitude, voltage, whatever you can call. This is an analog signal. So basically, there is a signal at any point of time, right? The signal is present at all times. So when you're speaking or you're shouting, it's kind of analog. Problem ye hai, whenever you're trying to record this, if you actually try to record, how many points are there on this line? There are infinite points on the line. And tell me, if you try to record each and every point, you need infinite data. So what the digital recorder does, we approximate it. So in digital, what we do, instead of recording everything, we record only few points. So the curve actually kind of looks like this. So you're recording actually some points. For example, let's say, if you record my voice, right, let's say at a rate of 1 bit per second. You know what is the meaning of this? So every second, the recorder will take one sample, 1 bit, and it will play for 1 second. So you know what will you hear? This is what you'll hear. It will just record 1 bit and it will play for 1 second. Suppose if you tell the recorder to record 10 bits per second, matlab it will take 10 samples of my voice in 1 second. So during that 1 second, it will record 10 spots and it will play them for 1/10 of a second. So your voice will look like, it will be like a noise. If I tell the recorder to record 1000 bits per second, now you start hearing your voice a bit. You'll actually start making sense. So when you say 128 kbps, the meaning of that is 128 kilobits per second. So you're telling the recorder 128,000 samples are being recorded every second. So in 1 second of your voice, the recorder will take 128,000 samples. So when you say 320 kbps, so basically you're breaking a curve into small pieces and you're adding them. And what you see is this. This is a 320,000 samples per second. This you actually observe it everywhere. You know, you have never seen a circle on your computer. You know that? You have never seen a circle on your computer. Forget about a circle. You have never seen a curve on your computer. Because if you see how your computer works, ever heard about this thing, pixels? So the screen which you're seeing right now is actually a combination of a lot of pixels, right? So if I actually just exaggerated this, when you ask a computer to draw a circle, you know what it is drawing? Your computer is actually drawing this. You're getting it? So it's like a circle, but computer is actually drawing this. Computer doesn't know how to draw a circle. This is what it is drawing. It happens so finely, you think it's a circle. That's what you call as pixel density. When the number of pixels are so high, you will think it is like a flat line, right? You must have seen, ever played a Nokia mobile with snake game? How does a snake look like in Nokia mobile? It looks flattish, right? These are pixels, isn't it? So when the snake wants to go from here to here, you know what will happen? This pixel is switched on, this pixel is switched off. So it gives you an illusion the snake has actually gone forward. Isn't that how the snake moves? Did you ever see a railway station में numbers on the, you know, the screen? How does 8 look like? Like this. Because these are just pixels. I hope you're getting it. This is all digital. You can do this. You take a photograph and zoom in. You'll observe, you'll see the pixels. At one point, the whole thing is gone. So you have never seen a curve on a computer screen or a TV screen. Never. It just gives you an illusion. So when I'm drawing this circle, it looks like a circle. But if you can actually zoom in, this still looks fine actually. At one point, right, you will start seeing. Let me take much bigger pen. You will see. This thing has a very good density, actually, Samsung. So yeah, but I hope you got my point. If we keep on zooming at one point, right, you'll start seeing pixels actually. This thing is pretty highly zoomed in. So you will actually find pixels here somewhere. Okay. I hope you got the point, but so there. So you have never seen a curve on a screen before. So keep that in mind. So great. So that is the basic theory of it. So how do we use this actually? So how do we calculate it? So this is the idea, right? So you got a curve here. Let's say the points are going from x1 to x2. You have taken a very small curve, right? Let's call this thing delta x at a position xi, and the height is yi. So you're assuming, so we took a small rectangle with xi as a coordinate. This is how it looks. This is delta x and this is y. So this is where we do. So delta ai, this is the area of the ith rectangle, which is yi into delta x. So the area under the curve is the summation of all these things. Will be summation all the area of the rectangles where the rectangles ka area, right? X coordinate will go from x is equal to xi to x is equal to x2, x1 to x1, x1 to x2. Problem, this still has some error. You don't get a proper area. This has error. And this symbol sigma is called summation. I hope you know that. So now how to decrease the error? What if delta x tends to 0, then the error also will tend to 0. If you keep those 2 points closer and closer and closer, if you bring them so close, you can assume almost the error also tends to 0. So this is the actual formula becomes like this. So area under the curve should be written as limit delta x tends to 0. Matlab, you have taken the rectangle to be so thin, you can almost assume there is no error in that. Sigma x is equal to x1 to x is equal to x2. Don't worry too much about the theory part. It is just for your understanding. AI. Now again, since we are lazy people, every time who will write this delta? So basically this is summation of all small rectangles from x1 to x2. That is the meaning of it in verbal way. So you can just replace this limit and all this thing with one symbol like this. We call it an integral di, where this is nothing but integral yi dx, limits from x1 to x2. I'll tell you what it means. This x1 is called lower limit. This x2 is called upper limit. So basically initial to final. So basically sigma means summation. This symbol, right, is called integral. The snake kind of thing. This is also summation only. There is no difference with that. But it is a summation of very small parts. So whenever you add very small parts, instead of using sigma, we use symbol called integral. So this formula becomes area is equal to integral, and we know for the function y is equal to f of x, the curve. If you take this curve y is equal to f of x, the function actually becomes integral f of x dx. Limits will go from x1 to x2 or x initial to x final. So this actually gives you the area under the curve. Now how to calculate this? Let's see that. But I hope what you're understood what you're trying to do. We started with a rectangle and then we said we want to find area for a curve, but I can't find directly. So I took a very small pieces, but small pieces ka problem ye tha, they're giving me errors. Then I made the pieces so small, I could almost neglect the error. And then I end up with something called an integral. So basically, just to tell everyone, I'm adding very small parts. I'm using the symbol integral. I hope you're getting the logic there. So basically all this stuff now that you replaced with this, that limit delta x tends to 0, blah, 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 all that. Clear? I hope everyone got the theoretical part. Technically speaking, we really don't care about all this. Physics may, you won't need all this. You just have an idea what it is. Any doubts on this, please ask me. Anyway, you're confused exactly what happened. That's it. You just need to know the basic idea of like, okay, what are you doing in integration? So integration ka basic idea is this: whenever something is changing, we can't calculate directly. So you have to take small pieces and add them. That process is called integration. That's it. Just keep that simple. This what will happen to delta x, right? Forgot kya? Limit if delta x tends to 0, right? Then we call delta x as dx, na? If delta x is very small, what will happen to dx? If delta x is very small, we call it dx, isn't it? We did in differentiation. And y is f of x, na? So I just replace the y coordinate with f of x. So at any particular point here, this will be the height. Y is f of x, function of x. F of x is nothing but y coordinate, Monica. That's it. Okay. Now let's see this thing. Now one thing you need to remember: if you have a function, if you differentiate the integration of a function, keep this in mind. So if you have an integration and if you differentiate it, you get the function back. Just remember this one trick. It will be quite useful to get the results. So basically, when we differentiate an integral, we get the function back. There are like 5 to 6 results which you need to remember. And we have only 2 conditions. We don't have chain rule, all that stuff we don't have in the integration. Only thing I'm worried is don't get confused between integration and differentiation formulas. People goof up that a lot. So whenever we differentiate an integral, we get the function back. That's it. If you know just one technique, it helps a lot. So basically, integral means what? Adding into small pieces. What is differentiating? Break into small pieces. You get the pieces back. Clear? Can I turn the page? So we're going to write the results. Note it down, right? If you know it is great. If you don't know, you should make sure to note it down. So f of x, like I said, applications are very important. The basic stuff is fine. F of x dx. So the first function we will deal is x power n. So if you integrate x power n dx, the formula is given by x power n plus 1 by n plus 1 plus a constant. This formula is valid for n not equal to minus 1. So here if you see, right, this is called indefinite integration. What is the meaning of this? The limits are not given, meaning you're not telling me you want the area from where to where. Therefore, we have to add that constant extra. That is, we don't know we want area from where to where. We don't know the upper and the lower limits. Up to what point we want area. Yeah. Because you said area under the curve, from where to where you want the area. It can be anything. We don't know up to what point we want area. So we include that constant term. So how do you know whether we have to put limits or not? There are 2 ways. I'll show you both. So don't worry, you will practice a lot of problems. Now, remember I told you just now something. If you differentiate a function, the integration, you'll get the function back. So if you differentiate x power n by n plus 1, see what do you get? N plus 1 differential of x power n plus 1. This will be 1 by n plus 1 into n plus 1 by x power n plus 1 minus 1. You get x power n back. This is what I was saying. If you differentiate this function, you get this function back. Check. But here, this is the main formula to remember. Let me show you with limits. See, this is what the main thing you have to remember. So if it is x power n dx, if the limits are x1 to x2, the meaning of this is you want the area under the curve from x1 to x2. I'll give you some examples also. But listen carefully how to apply the limits. So this formula will become x power n plus 1 by n plus 1. Integration is over. We just put a vertical line on the right side, x1 to x2. The meaning of this is integration is completed, but we need to put the limits yet. Integration is over, limits have to be applied. That is the meaning of that vertical line to the side. Then how do you apply limits? First put x2. We get x2 to the power of n plus 1 by n plus 1. Then put x1 to the power of n plus 1 by n plus 1 and subtract them. Meaning this term which we have, the first term here, this is area up to x2. This is area up to x1. And if you subtract them, you get area between them. Let me take a simple example. Let's say someone gives you integral x square dx. So basically here the function y is equal to f of x is equal to x square. Let's say limits are from 1 to 2. So integral x square dx 1 to 2. This will be x cubed by 3. Remember the formula, n is 2 here. So x to the power of 2 plus 1 by 2 plus 1. Be careful, huh? This is what I'm a little scared of. People will do differentiation of formulas. 1 to 2, integration is over. So this is x cubed by 3, limits 1 to 2. So first put 2 ka value, 2 cubed by 3. Put 1 ka value, 1 cubed by 3, and subtract them. That is 7 by 3. You know, what did we find? So for this curve, y is equal to x square. You found the area between x is equal to 1 and x is equal to 2. This area is 7 by 3. There, now you know how to find area under the curves. Meaning I'm showing you for areas, but we can actually do it for a lot of different things. Just like differentiation, we started with slope, no? Then we did it for different things. So I'm showing you areas because that's an easier way for you to understand. But then we will apply this to multiple steps. Please have a look at this page. It's quite important. So this is your first formula, x power n. Comes a lot, literally a lot. Like I said, different integration is not difficult. Applications are a headache. But please have a look at this, how it is. Anyone not convinced, not clear, confused, please ask. So this is called a definite integration. If you have limits are given, it is called definite integration. Limits are not given, it is called indefinite integration. I'll just add it here somewhere.
So,
This is R.
so can you explain what do you mean by area up to x1, area up to x1?
You didn't give me the limits, but you have a curve here. So up to this point, all this area is area up to x2. Up to here, all this area is area up to x1.
Okay.
If you want between them, subtract them, right?
Yes.
This is called definite integration. Please check. Clear? We will do more problems, don't worry. This formula is that. So x power n plus 1 n plus 1. The second one, integral sine ax plus b. x1 to x2. This is given by minus 1 by a. So see, I'll tell you one thing, how to remember this in case you forgot the formula. Think of like this. After differentiating, I'll get some answer. Think of like this. What should I differentiate here so that I will get this as my answer? Are you getting the logic? So basically, you're asking the question actually, what should I differentiate here so that I should get this as my answer? Isn't that the logic? Because when you differentiate the final thing, you should get the function back. So think of like this. So you want to get sine. So sine ke liye kya differentiate karna padega? Cos, na? But whenever you differentiate cos, what will happen? You get a minus sign. And then you have to differentiate the function inside also, ax plus b. So you get a minus 1 by a. Check it out. If you differentiate this, you'll get sine ax plus b. Limits x1 to x2. Then what to do? Integration is over. Substitute the values. Put x2 cos ax2 plus b minus cos ax1 plus b. That's it. Integration is done. This is a sine ka formula. Everyone should copy this down. Cos ax plus b ka integration. Again, think about it. If you want to get cos, you need to differentiate sine. But if you differentiate sine ax plus b, you will get into a in the numerator. So 1 by a sine ax plus b. You need to by heart these things. Right? Max will teach you in more detail, but you need to by heart these things. So just think of like this logic. If I differentiate this, I will get this back. You can verify that. Sine ax plus b ka differential will be cos ax plus b. Then differentiate whatever is inside, you get an a, and there's an a outside here. A cancel ho jayega, cos ax plus b aayega. So this will be now substitute x2, ax2 plus b, then substitute x1 and subtract them. Check. Haan, Niranjan, clear with this? Maulika? Got this? Ritu? Go there. Ritu is gone. Maulika, clear, na?
Yes.
Mayuka, clear? Vidyut? All clear with this page. Can I go ahead?
7.
Yeah. Let me show a small example. Turning the page.
Yes.
Let's say if you give me integral sine x dx, let's say from 0 to pi by 2. Now this formula, right, looks like sine ax plus b, where a is equal to 1 and b is equal to 0. So the formula will be minus 1 by a cos ax plus b. Limits from 0 to 90. So a is 1, b is 0. So that is simply cos x. 0 to pi by 2, substitute the values, cos 90, then substitute this thing, cos 0. This will be minus 1, 0 minus 1, which is 1. What is the meaning of this? If you actually plot the sine graph looks like this. Y is equal to sin x. Everyone knows, right, sin x graph? So you're asking, so this is x is equal to 0. This is pi by 2, sine 180 is again 0. So you're asking this area. This area is 1. That is the physical meaning of it. So when you say, I want the area under the curve sin x from 0 to pi by 2, what you're finding is area from 0 to the red shaded area is actually 1. Clear? Any doubts on this? Great. Next one. It will be having units, right? Square units or something. The fourth formula, e power ax dx, exponential. This will be 1 by a e power ax x1 to x2. So 1 by a e power a x2 minus e power a x1. Integral 1 by ax plus b dx. This is ln ax plus b. Ln ka differential hope you remember 1 by x plus b. x1 to x2. These are the 5 formulas which you need to mark up. ax2 plus b minus ln ax1 plus b. A simple case will be integral 1 by x dx. This is actually ln x. Generally in physics, these are the 5 examples. These are the 5 things actually mainly. We do have some variations of this that we will see later on. But if you got these main 5, I think you can handle most of the calculus, in integration in physics. And luckily, we don't have chain rule, we don't have division rule. We have a product rule, but we don't require in physics. So we just have 2 simple rules after this, and integration ka theory is done. Applications, and we'll do a lot of practice on this once, and then we'll do applications later on. Have a look at these 2. Okay. Turn in the page. And the 2 identities we have, if you have a f of x dx, a is a constant. So you can just put that a outside and integrate. So example, if you have something like 3x dx, 0 to 1, you can just put the 3 outside and say, right, x dx from 0 to 1. This is x power 1. So basically n is 1. The formula will be x power 1 plus 1 by 1 plus 1. Limits will go from 0 to 1. So that will be 3 into 3 by 2 x square 0 to 1. So 3 by 2 into 1 square minus 0 square is 3 by 2. Second one, if you have a function f of x plus or minus g of x dx, if you're adding 2 functions, you can just split them into individual functions, f of x dx plus or minus integral g of x dx. Example, if you have to integrate something like sin x plus e power ax dx, you can just simply integrate sin x separately and e power ax separately and just add them. That's it. We have these only two identities. We do have a product rule, but in physics, you will never see it coming. F of x into g of x integral. We don't need it. So if you know these 5 formulas and these 2 identities, integration ka basics are done. Mathematical part is done.
That rule you have to solve by substitution. Bro.
No, wo alag hai. Product rule alag hai. Integration by substitution is different. Integration by substitution in physics, we have 3 to 4 varieties that I'll show you later on. If you know those much, it is sufficient. And don't worry too much about this integration part, because as time passes, right, as we keep using them in more different chapters, you'll actually get used to it slowly. Like I'm saying, integration is not difficult. Application, converting the form into an application is difficult. I'll show you one application today. Time permits, but let's see some examples. Copy it, everyone. Let's see some practice problems, and then we'll go ahead. So I'll give you the functions you have to integrate.
So can you go back for a minute? Yes, sir. Thank you.
Root x dx 1 to 2 integral 1 by 2 root x dx (0 to 1) integral sine 3x dx 0 to pi by 12. Let's say pi by 6. Integral x square plus 1 whole square dx integral e power minus 2x dx 0 to 1 integral sine square x dx from 0 to pi by 2 integral cos square x dx from 0 to pi by 2. Get them all. You have to just use a regular formula and finish it off. Try. I'll get 3-4 minutes. Let's finish off all. Just give it a try. Get some water and come. Done. Go to the first one. So first one, n is half. So the formula is x power n plus 1 by n plus 1. Limits will go from 1 to 2. So that is nothing but 2 by 3 x to the power of 3 by 2. Limits will go from 1 to 2. So 2 by 3 limits 2 to the power of 3 by 2 minus 1. Check. Second one, let me show it on the next page. So half integral 1 by root x dx. You can write this thing as half integral x to the power of minus half dx. It's 0 to 1. No? So this will be half into x power minus half plus 1 by minus half plus 1, 0 to 1. So that is half, 2 will go up, and this will be root x from 0 to 1. So that is 2 will cancel. Root 1 minus root 0, that is 1. Check. So for this, the answer is 1. Finish all the rest. Try. I get 2-3 minutes. Just brute force, there's nothing there, just formula substitutions. See the appropriate formula, put it there and finish it off. I'll show you 1 2 applications today, and then we'll do more problems in the next class. Third answer will be minus 1 by 3 cos 3x 0 to pi by 6. That will be put pi by 6 there, it will become pi by 2, and this will become minus cos 0. Cos pi by 2 is 0, that is 1, so 1 by 3. I hope 1 to 3 are clear. X square plus 1 whole square dx kya karna? Expand it, a plus b whole square, and then integrate each term. Try. Everyone should try. Get them.
And for the problem, we can do it this way also, no? By we can reverse
Which
that
one?
for fourth one directly. The 1 by 2x.
You can't use chain rule, right? Integration में chain rule नहीं है. Integration में there is no concept called chain rule. So don't do that. Integral of something and इसको अंदर integrate करो. Don't do that. That doesn't exist. (18 by 15). Integral x square plus 1 whole square dx. Limits are from 0 to 1. Expand this. This will be x power 4 plus 2x square plus 1 dx. The x power 4 का integral is x power 5 by 5. 2x square का integral is 2x cube by 3. And 1 dx का integral is x. Be careful here. Huh? If you just take integral dx, right? This is simply nothing but x power 0 into dx. So this is x power 0 plus 1 by 0 plus 1, which is x only. Or you can simply say integral and d will cancel, you get x outside. But okay. Limits 0 to 1. Now substitute 1 in this. 1 by 5 plus 2 by 3 plus 1, and the second term will be 0. How much is this? 1 plus 1 by 5, 6 by 5, 6 by 5 by 2 by 3. 18 plus 10, 28 by 15. Jasha, check karo. You got 18, I got 28. So maybe I'm wrong. I got 28 by 15. Others? Okay. It's 28 by 15 it seems. Others, try. Why are you guys not typing answers? If you got the answers, you should type here in the chat box. Or else I will think you're not understanding or you're sleeping. Try. Get the other 2, 3, 5, 6, 7. Finish it off.
Can
Fifth
you
is
do
easy.
the working for the fourth one?
Clear?
Yes.
Look at the fifth one. This is e power ax, na? So minus 1 by 2 e power minus 2x. Limits will go from 0 to 1. Be careful, e power 0 is not 0. E power minus 2 minus e power 0. If you just set that minus inside, you end up with half into 1 minus 1 by e square. Sixth and seventh are good, right? Sixth and seventh will come a lot. Sine square and cos square integral pops up a lot. 6 is not defined. Why? 6 you can solve it. There is no, I didn't give you a direct formula, but there's a way to do it. Think for a 6 for about a minute. Again, I'm just teaching you the integration and differentiation, what is only required for physics. I'm not teaching a bit more. So by chance in your classes, they're teaching you something much higher level and this thing, not an issue, no problem. You can just solve that, paste the booklet if you're doing. That should be sufficient. But none of that will come in physics. Max will teach you for 3 months and then this will look like a joke. What you're doing is like a small puppy. They'll teach you a dinosaur. What you're more interested in applications. How to do the sixth one? Any ideas? There is a hint in basic max. Anyone remembers this?
Yes, sir.
You can convert sine square into 1 minus cos 2 theta. This integration you can do, na? You can't do for sine square directly. So you have to convert this into 1 minus cos 2 theta and 1 plus cos 2 theta. Try. I'll give you a minute now for the sixth one. See. So integral sine square x dx limits from 0 to 90. This can be written as 1 minus cos 2x by 2. So just take out that half outside and you end up with integral dx minus integral cos 2x dx. This will go from 0 to 90 and this will go from 0 to 90. So dx ka integral is x only. So this integration is done. Cos 2x ka integral will be half sine 2x, 0 to pi by 2. Substitute the values. So x will be pi by 2 minus 0 is pi by 2. This will be half sine 2 pi by 2 is sine pi and minus sine 0. This is 0. This is also 0. Sine pi, sine 180 is 0. Sine 0 is also 0. This is 0. This is also 0. You're just left with pi by 4. Check. Ha, Palak, you got it right. Have a look at this. Do you know what does this graph look like? Sine square x graph. Sine square x meaning it will never be negative. The graph will be actually always like this. This is a sine square x graph. So this is 0 and you're asking me this is a pi, right? This is pi by 2 actually. Sine square x, no?
That is pi.
That is pi actually. So you want the area from 0 to pi by 2. This area we found. Clear? What about the other one? That is the same thing actually. If you see now, this will be cos square x. Seventh one, ये होगा 1 plus cos 2x. This will be plus. This will be plus. This will be plus. Same answer you get. Check karo. Only then the graph will look a little different. Graph will look like this. This is pi by 2. I'm asking you this area. The area is same. The only difference between cos square and sin square x, it will be 1 minus and 1 plus. Anyway, the second term is becoming 0. It doesn't matter. Have a look at this. All clear with this? Anyone has another doubt? Not clear with this? Please ask. All this thing we can say it's problem 1. No. Previous page, this one.
So can you just go to the next page? Yes, sir. Thank you.
Clear. Now let's see same thing, but in more verbal form. Okay. They'll ask you a question like this. Find area enclosed by the curve y is equal to x square and y is equal to x cube. Let's take it simple. Y is equal to x and y is equal to x square. How do you do that if I ask you? Find the area enclosed by the curve y is equal to x and y is equal to x square. I'll just show the diagram for you. Y is equal to x is this line. Y is equal to x is a straight line passing through origin. Y is equal to x square is a parabola. I'm asking you to find the area enclosed between them. This area I'm asking. We want this area. How will you find that? To find the area enclosed by the curve between y is equal to x, which is a line, and y is equal to x square, which is a parabola. If I actually draw the whole thing now, y is equal to x is a line passing through origin. Y is equal to x square is like this, a parabola. So when both of them are overlapped, there is some region which is stuck between both of them. What is that area? Think. Try. I'll give 2-3 minutes. This is just for a show. Physics may little rare. We will rarely encounter these things. Max may you will get this a lot. Okay, someone got 1/6. Let's see. Others try. I'll give you a minute or two. You have to substitute the limits there, Ronak. What is this point of intersection? Where will they meet? They will meet somewhere, right? So, this point of intersection क्या होगा? Isn't it 1, 1 everyone? Y is equal to x. If you substitute the values, y is equal to x and y is equal to x square. मतलब x is equal to x square. That means x is 0 or x is 1, right? So they're meeting at the origin and they're meeting at 1, 1. There are 2 points. So indirectly what we are finding actually. So this is nothing but this line plus this line. So you're finding the area up to 1, 1. That is this area. Let's call it A1. This is 1, 0, which is half into base into height, which is half. This is 1, 1. You are asking me to find this area. This area, let's call it A2, is nothing but integral f of x dx. And here y is nothing but f of x is nothing but x square. So basically you're asking me to find the area integral x square dx from 0 to 1. So this will be x cubed by 3 by 0 to 1. This is 1/3. That is this area. So if you take the difference between them, so this is nothing but enclosed area is A2 minus A1 minus A2. which is half minus 1 by 3, 1 by 6. Easy. Please check the idea there. So we found the area under the triangle, we found the area under this thing, and if you subtract them, I hope you can clearly see there. You get that area in the middle. Because the triangle will be above the curve. They will meet at 1, 1. Clear? Let's see one more like this. Any doubts on this? Anyone didn't get this? Please ask me. This finding area between the curves is really not important. So it's not really important, but just to get the practice of integration and that thing. I'll give you this as one as an assignment. Let's see some applications, okay? So the major applications we have in integration is finding areas and volumes. Right. Now, whatever I'm teaching you, right, you have to kind of mug it up. Meaning, whenever you see this kind of question, you need to understand, okay, I have to take an element this way. Let's start with something simple. If you take a disk, let's say we have a disk here of radius r, and you want to find the area. I know it is kind of obvious, we know the answer, but exam they won't ask like that. You will have a disk which is changing mass, and you have to do something. So the first thing you need to know, whenever you get a shape, how to choose an element. So whenever you get a disk, the element is a thin rings. So just listen, you'll understand. Rings with small thickness. What do you mean by this? So we have a disk here. Consider a ring of radius x and thickness dx. The moment you use the word dx, matlab dx means very, very small, negligible, 0.00000, something like that. So what we're doing here, from the center at a distance x, you have taken a circle and you have taken a thin thickness. So listen to this process. So this thin ring which you have taken, if you take a scissor and if you cut it, and if you open this, what you get is a trapezium kind of thing. And if you look at this length will be 2 pi x. Everyone agrees? The circumference. And the height of this rectangle will be dx. Since the dx is so small, you can almost treat this like a rectangle. What we get, dA, that is a small area of a thin rectangle. This is the area of that thin rectangle. Which is also area of the thin ring. Again, you know what I did? At a distance, I took a thin ring of thickness dx, and I took a scissor and I cut it off. And when I opened it, what I got is a rectangle, thin rectangle of length 2 pi x and the breadth height dx. So we get the area dA will be length into breadth 2 pi x into dx. This is the area of one ring. So if you want to find the area of the disk, you have to add the area of all the thin rings. So area of disk will be integral dA, basically the area of the rings. And the rings are starting from where? X is equal to 0 is the first ring at the center. So at the center, x is equal to 0, that's the first ring. The last ring will occur at x is equal to r. So the limits will go from x is equal to 0 to x is equal to r. That is the meaning of limits. Substitute here, 0 to r, 2 pi x into dx. 2 pi is constant, integral x power 1 dx from 0 to This is nothing but 2 pi x square by 2, limits will be 0 to r. 2 will cancel. You end up with pi into r square minus 0, which is pi r square. That is the area of the disk. Did you see? Actually, did you observe? Integration is very easy. Sirf x power 1 ka integration tha. But the headache is converting these elements. Again, listen to the process how we did. Don't worry too much about it. Next class, we'll be doing all these kind of things. I'll be teaching you more variations of it. But this is what we are interested in actually in integration. We're not actually interested in the mathematical part. And then currently, when we are doing it for seniors recently, I'll just show you what type of integrations we deal. There, this is what I was showing them. See, did you see the ring? You get complex integrations, but wo alag story. But the main idea is to get the elements. Here we take small arcs. There, we are choosing elements. We integrate. We'll encounter a lot of questions like this. We take elements. We will even encounter, hemispheres, spheres, solid spheres, a lot of shapes we will see. In total, I think there are primarily 4 to 5 shapes which you need to remember. If you got the hang of it, it is pretty easy, but you need to get used to it. So for a disk, this is how you take an element. 12th standard HSC, there is an derivation based on this, but this is how you choose elements and do it. Please have a look at this, what I did. Clear? The actual question in this is like this. You have a disk whose mass is changing with radius. Matlab, this disk is made with, let's say, iron or something in the center, and as you're going out, it is becoming aluminium. So the density of the mass disk is not constant, it is changing. Then they'll ask you find the mass of the disk. You have to use integrations and solve. Anyways, this we'll see in the next class. We'll not do too much, we'll get confused unnecessarily. But make sure to go through the integration problems, and integration, I'll send you some basic sheet today. But these applications of areas and volumes is more important. We'll be doing it in the next class, so don't miss it. Did you see the actual integration is quite easy? The headache is getting till here. Calculus ka yehi headache hai har bar. Getting that equation is a headache. Okay, so with this we'll wrap up for the day. Now we will see the doubts in that assignments which I sent you. Hope everyone tried. Differentiation ka I sent you how many sheets? 2 or 3? How many sheets did I send? 2, right? Yeah. Okay, so with this will wrap up for the day. So anyone has doubts, anything, please stay back and ask. Also free to